It's a big day for geometry. We are going to go through a rite of passage for geometry students. We are going to be doing compass and straight edge constructions in geometry. And what this is the ancient Greek mathematicians, they'd sit around in their togas and they'd challenge each other to competitions of what they could do, what they could figure out with just a compass and a straight edge. Now, you are not allowed to use your ruler side of the ruler today because that would be cheating. You must use the blank side because that is the straight edge. So we're allowed to draw straight lines, and we're allowed to make circles, and that's it. And we're going to see what we can accomplish. Geometric constructions. So you want to be on my geometry team. We're going to start out with some practice rounds to make sure that you are proficient at drawing circles and straight lines. One helpful hint is that you're going to want to have a notebook or something underneath your piece of paper, and that's because that's going to help you sort of embed that pointy thing just a little bit so it sinks in a little bit. If you're using it on just a table, it tends to slip a little too much. So first pro tip is to put a notebook or something underneath. Next, we're going to try to make a bullseye, just as a warm-up. So do you remember how to handle this compass? We're going to loosen it up, get it to the size we want. So that'll be my radius size. Tighten it up. And here's another pro tip. I like to plant the pointy part, and I am more of a fan of turning the paper. For me, that just works better, usually. Now, what I mean by a bullseye is I want you to try making several different size circles and using that same center point every time. Here, I'm going to show you, if you're not turning your paper, you're going to have to really make sure that that point stays in the same spot. So I just want you to practice making a bunch of, they call them concentric circles. Concentric because they all have the same center. Get some practice rounds in, and then we'll try a little more. Now that we have some practice in drawing circles, we're going to step up our game. Let's move on to another warm-up here. I would like you to draw two intersecting circles, so it's going to look like a Venn diagram of sorts. They don't have to be the same size. Your circles will stay the same size unless you loosen up your compass and make them different, but so draw me a couple circles. Very Venn diagrammy. And now it says use your straight edge, not my ruler, of course not, my straight edge to draw the line that contains the intersection points. So I want you to find the 2 points where those circles intersect, and any 2 points determine a line. So we are going to draw the one line determined by those 2 points. So that was kind of a common move that we're going to use when it comes to game time. Next exercise, we're going to try to copy this Mickey Mouse looking thing down to these 3 points. And maybe that's a little challenging because I can't actually measure any radii or anything. So the way we work around that, the way the Greeks would do it, is they're going to use their compass as their measuring tool. So I'm going to start with circle A, and what I'm going to do is I loosened it up and I'm going to set it so that the pencil will hit the exact edge of that circle, and then I'm going to try to tighten it before it moves. Oh gosh. Tighten it up. And then once I'm there, then I can bring that down here and copy that. So that should be a congruent circle to that first ear of the Mickey Mouse. I'm going to continue that and just readjusting my compass each time to the appropriate radius. An exact copy, 2 congruent Mickey Mouses. If you made it through warm-ups, I think you're ready for game time. Our first challenge is that we are going to try to find the exact midpoint of this segment. And if I were a cheater, I'd grab a ruler and I would measure where the exact center is. But I'm not a cheater. I'm following the rules of compass straight edge constructions. So this is just like a famous little play. So I'm going to teach you how we do this. So step 1 would be to take your compass and you want it set so it's more than halfway across the segment, and you can just eyeball that. Get your compass set so that it's more than halfway. Tighten it nice and tight. And once you tighten it, we're going to keep the same size circle for the whole rest of the thing. All right, step 1, you're going to take your pointy part, place it on the end point of the segment. And we are going to, they call this swinging an arc. You don't have to draw the entire circle. You can just swing an arc that sort of covers this area. Swing an arc. Now, what that does is it finds all the same distance points away from that end point. We're going to do the same thing without changing the radius of that circle. We're going to put the pointy part at the other end point of the segment. And we are going to swing another arc. Swing an arc. And the resulting picture always reminds me of a 2-tailed Jesus fish. Can you guess what we're going to do to find the midpoint? You probably realize that the midpoint is somewhere in the fish, but what we're going to do is kind of like that Venn diagram. We're going to take those 2 intersection points, connect them with our straight edge, and guess what? If we did everything really precisely, that should be our midpoint. Tick, tick. And you could even check with a ruler, I'll allow that, but that's how we're going to construct a midpoint. An extra little bonus is that makes a right angle there, which is kind of cool. But that's how we construct a midpoint of a segment. We are not allowed to use a protractor, so how are we going to bisect this angle? Normally we'd measure the angle, divide by 2, and put a mark, but this time we're going to have to do it with nothing but a compass and a straight edge. So let me show you how this will work. Step 1, the radius doesn't really matter, but I want you to put the point of your compass at the vertex of the angle, and we are going to swing an arc so that it intersects both points. Sorry, both rays, right there and right there. All right, there's 2 more arcs we're going to swing. And can you imagine where we might plant the pointy part of the compass now? It's going to be at these 2 intersections. So 2 more arcs, and we're going to plant the pointy part at those intersections. And what we're going to do is you want your compass to be open a little more than halfway across that angle. So we're going to swing an arc, swing an arc, and it just sort of makes a little Xbox logo out there. All right, so we're done with the compass. How are we going to cut that angle in half? If you thought maybe it had something to do with the intersection of those last 2 arcs, you are correct. Can you see it? We're going to take our straight edge and connect the vertex to that point, and this ray winds up cutting that angle into 2 congruent pieces. How cool is that? Bisector. Swoop, swoop. If you want to check it with your protractor, it's an amazing thing. So it's kind of an intro to geometric constructions.